that we like. We like this one for some reason, right? It just fits our eye. And a trapezoid, you probably saw in class, a trapezoid is a triangle where the top has been cut off, like that.
Mhm.
Was that shown in class?
Mhm.
Great. But really what you're looking for, and this is the key, is it's one set of parallel sides. And it doesn't have to be drawn this way. It actually can be drawn vertical. This is the one your book will do a lot of. They'll kind of give you something like that, or they'll go the other way and they'll make something really odd looking like that. So you have to be prepared for that, but you're looking for one set of parallel sides, right?
Right.
That's the key distinguisher. And they probably didn't even do this, but in terms of quadrilaterals, they are all subdivided by the number of parallel sides that they have. So for example, kites, they have no parallel sides. And then your rhombus, square, rectangle, parallelogram, they're all going to have two parallel sides, and then trapezoids are down here in the middle. All right, so having said all that, that's I feel like there's a 2-minute introduction, and I throw the formula at you, and then we go right to a problem here. So 2A, I love how they give you problem 2, but it's really 4 problems.
I know.
You might as well just tell you it's A through D. So area of a trapezoid, a couple ways to remember it. It's the average of the bases, which is really, I know it's 1/2 B1 plus B2, but think of it as the average of the bases, the ones that are parallel. So you add the bases up, divide by 2, and then you multiply by the height. Now, if you're doing this by hand, you would divide before you multiply. So it's 12 plus 13, 25 times 3, 75. So for whatever reason, your book doesn't really seem to like give units, which I don't understand, but they give units. So does your teacher want you to put like units squared?
Yeah.
Okay. And that's good to do, but why can't they just give you the units in the problem, right?
Right.
Not sure. But this book is about as old as I am, so it's something to consider. Problem B. Problem B. Normally they give you the base and the other base, but this time they're giving you what's called the mid length or the mid. I think it's mid segment or mid length. I don't know. You remember from class what they called this?
I think midnight.
Mid length. So that's the average. That one is the average of the B1 and the B2. So normally you have to take the average. This time you don't. It's just 12 times 6 for your area. Is that okay?
Yes.
Okay, great. Now, part C. Part C is kind of leading into, sorry, that's 72. Part C is leading you into problems where you have to use your knowledge of triangles. So a lot of problems we're going to look at today are going to have something to do with a triangle. All right, so notice we really need the height here. Because you have base 1, you have base 2, that's fine. How do we find the height? Well, always good to kind of draw the triangle off to the side. What is the length here, this base length of the triangle?
17 minus X.
It would be, but we know X. We know X is 9 because these are parallel.
Oh, 8 then?
Yes. And then how do you find the third side of a right triangle? What's in your toolbox of ways to find it?
Is that one, can you make it, is that one 8 as well?
It is not 8. It comes from a squared plus b squared equals c squared, or Pythagorean triples.
Right, okay.
But let me drop this in the chat here. This is a reference sheet that I found that's better than anything else I've found that's got areas and volumes in it. You'll be doing volumes up next. If it were me, I would print it out, have it, it's one piece of paper. It's not, 3 or 4 or 5, right? And it's got everything. It's got Pythagorean theorem, it's got your areas, it's got some distance formulas, stuff like that. Really useful stuff. So I'll refer to that some today, but could you calculate that third side for us, please?
Yes. Um, 6.
Yes, H is 6. Very good. So then the final area of the trapezoid, you have to take the average of the bases. One base is 17, the other base is 9. We'll go ahead and find the average of those, add them up, divide by 2, and then multiply by the height, please.
Okay. Um, 78.
Okay, 78, perfect. All right, let's go on to letter D. So another trapezoid, big surprise there. They give you 2 bases, okay, base 1 and base 2. This is not the height though. You have to calculate the height. They're helping you out though by showing you that because the sides are the same, you can drop down these altitudes and create a new triangle here off to the right. So this new triangle off to the right here has a hypotenuse of 13. Can we figure out the segment lengths? They are congruent, okay? And we don't have to prove that they're congruent. You're kind of past all that. You're almost to the point where you can say, if it looks like it, then if it looks like it, then it can be considered congruent. So the top is 21, the whole bottom is 31. What would be each of these? If you need to, you can call it X, but go ahead and solve for that.
Is it 31 minus 2x?
31 minus 2x equals 21.
Okay.
Or you might think of it as 31 minus 21, which is 10. That equals the 2x. Because the 21 is cut out, and you have 10 divided up equally among the 2 sides.
Okay. So x equals 5.
X equals 5. So now can you calculate the height of this triangle?
Yes. A equals 12.
You got it. Very good. So the area of the trapezoid is base 1 plus base 2 divided by 2 times the height, which is 12. You can calculate the average, add them up, divide by 2. You can take 12 and divide it by 2 and then add them up and multiply, however you want to do it. Go ahead and give me the final answer there, please.
Okay. Um, 312.
Say that one more time.
312.
312. Good. Okay. Right. So we're on to number 5. 5 is a working backwards question. And they also don't give you the shape. So it's always good, in my opinion, to draw something resembling a trapezoid. They tell you the height is 10, and they tell you the total area is 130. And what we don't know, it doesn't really matter. We don't know whether the bottom one is 15 or the top one is 15. It doesn't really matter. You can just label one. It doesn't really matter. Sorry, the area is 130, not a 130. So working backwards, we know that it's, and we'll just call this x, 15 plus x divided by 2 times 10 equals the area. So normally we're given x, we would add it up, divide by 2 and multiply by the height. This time we're solving for x. So go ahead and take a look at that, see what you come up with.
Okay. Is it 11?
So if we add them up and divide by 2, yes, we get the right number. Yes, that is 11. Very good. All right, so next problem here is number 6. Number 6, lots of words on this one, but we do get a picture. That's nice. All right, straight wire stretches between the top of 2 poles whose heights are 30 feet and 14 feet. So this is that trapezoid where it's not really oriented the way we like, but these are the bases because they're parallel. Find the height of a pole that needs to be placed halfway between the original poles to support the wire. Assume that the poles are perpendicular to the ground. Hint, do you see a trapezoid on its median, etc. Okay. So because it's halfway between, we kind of saw this earlier. Let me scroll up here. You saw it right here. It's kind of this thing with the two bases, but it's rotated 90 degrees.
Mhm.
So what I'm not sure is clear, but it's just a visual exercise. This right here is the average of the height.
Okay.
That's, I mean, there's literally nothing more to do here. There's no area to find. It's just finding the average of those two heights and then giving the proper units.
Okay. Wait, I'm not sure what this one is asking.
For the average of the two heights.
So, oh,
They're the bases this time, but they're, in terms of the problem, they're the heights of the poles,
okay.
average of 30 and 14.
So just 22.
22 feet. Yes. Sometimes you have to say to yourself, what can I do with the two numbers that are given? And there's really a limited number of things you can do with two numbers. You can add them, subtract, and multiply, divide. In the case you find the average. Like, I think sometimes as a student you think, well, there's something else there, but there really isn't. Like, this book is very direct. It just gives you everything you could ever need. But here there's just a lot of words wrapped around it. It's overly complicated for what it's actually asking for.
Yeah.
Probably won't see that on, will not see that on a test request, but that's what you've got there.
Okay.
All right, these are moving into problem set B. As you know, B's get more difficult, more stuff to do each time. Find the total area of each figure. You really want the other base you don't have, and you really want the height, which you also don't have. Notice you just have more stuff that you don't have. You have to find it, calculate it, do something to get it. So in this problem here, this is a special triangle. Do you remember what kind of special triangle this is?
Uh 30, 60, 90 triangle.
Yes, yes, very good. Okay, so what that means is you can find the other sides without knowing two of the sides. So that comes from knowing the reference triangle. If you're given the hypotenuse, the short leg is x and the long leg is x root 3. So in your problem here, they're giving you the 2x side. What's the short leg side?
3.
3. And then what about the long leg or the height here?
3 root 3.
3 or 3. Good. So you can actually do this over here as well. This is 6, 3, 3, 3 root 3. This is 7 in the middle here. You now have enough to find the total area. Okay, you need to find the average of the bases, right? Base 1 plus base 2 divided by 2, and then multiply by the height. You have base 1, you have base 2, you have the height. You have everything you could need here.
Okay.
Your answer will contain a square root of 3 in it.
Okay. Is it 30√3?
For your final answer.
Mhm.
All right, so you got the average of the two here. You got 13, 7, it's 10. So yes, it is 30 square root of 3. Perfect. All right, so letter B. Next one here, letter B. All right, so this is two trapezoids, and sometimes it's good to sort of draw them separately, maybe separate them out. Not sure. If that's like something you would need to do because you're like, I can't really see them. They do have some overlap in information. But you just have to find the area of one and then add it to the area of the other. So will you calculate that for us, please?
Yes. So when you have the two areas of each triangle, then you add them?
Well, trapezoid. You just find the area of trapezoid 1, area of trapezoid 2.
Right, that's what I meant. Okay.
Yes, yes. You just add them together. I don't know. It's a weird question. Like, I don't know why they're not just saying,
Yeah.
but you do composite shapes either later on, or maybe they introduce them throughout.
Okay, 115.
Yes. First one is 65 or 55. The next one is, or no, 65 and then 50.
Right.
Maybe I said that wrong. Yeah, 65 and 50. All right, very good. On to number 12, which is a problem that does not contain the shape. It's decidedly more difficult when you don't have the shape because you have to draw it and try to get it right. Again, just draw your favorite trapezoid. You don't have to be accurate, just have to draw something. It says the perimeter of a trapezoid is 35, so that's all the sides add together, as you know. The non-parallel sides are 7 and 8. So we'll go 8 and 7. I'm just picking, doesn't matter. Those are the non-parallel sides. So if you really wanted to, you could show that those are the parallel ones and see if that matches kind of what you're thinking. Now the height is 5. Okay, so again, this probably is not drawn to scale, but it's good enough for what we're doing.
Yeah.
But we need to find the area. Okay, well, the area requires you to know base 1 and base 2, but we don't know that. But we know that the perimeter is 35, so we need to somehow use that. Any ideas on using the perimeter?
Um, no.
Okay, yeah, I have a little more in perimeter. Perimeter is all the sides added up. So base 1 plus 7 plus base 2 plus 8. So notice the perimeter is base 1 plus base 2 plus 15. And we actually know the value of the perimeter, right? Perimeter is actually 35, which allows you to subtract 15 from both sides. So the two bases add to 220. Any idea why that might be useful?
Um,
Think about the formula for area of a trapezoid.
can you divide it by 2 then?
Well, in the area of a trapezoid formula, you take the bases and you do divide it by 2, which means you actually don't need to know their individual values. You actually just need to know the sum.
Oh,
Yeah, so the sum 20, we don't know their individual ones, but that's okay. We do divide it by 2, and then we multiply by the height, which is 5.
oh, okay.
Questions?
No, thank you.
Yes. All right, so that's 12, 16. Oh, problems at C. Wow, they're really being challenging. Usually you don't get into the C's. That's for sure.
Yeah.
All right, here we go. Sides of a trapezoid are in the ratio 2, 5, 8, 5. Okay. Yeah, and you don't need to draw it accurately. Just get a drawing up. But there is kind of a way to do this, and I'm kind of keying in on the fact that there's 2 5s. Okay. Now, whenever you see a ratio, you probably saw this in triangles. You really look at it as 2x to 5x to 8x to 5x. You can always add the letter in there with them.
Right, okay.
All right. So what that means is we've got to figure out where do each of them go. Well, 5x and 5x there. That's somewhat possible. And then the smaller one will be 2x, and the bigger one will be 8x.
Right, okay.
But we want the height. We got to find the height, and that's where we've got a bit of a challenge here. So let's do this. Let's drop an altitude down. Okay. So these two segments are congruent that I've drawn there. That means that, and it's not drawn well, but 8x is the whole length. So if you subtract out the 2x, what is 8x minus 2x? 6x. And that 6x is divided up among these two right here. So that's 3x and 3x. How do we find the height of the triangle if we know that it's 3x and 5x?
The Pythagorean theorem.
But we're used to numbers. We're not used to doing it with variables. So ignore the variable. Let's say it was just 3 and 5. What would the height be?
Um,
4x,
Um,
right? It's a 3, 4, 5 triangle. 3, 4, 5, one of those Pythagorean triples.
right.
I know it's a little awkward because it's x's, but if you look at it without the numbers or without the variables and just look at 3, 4, 5, you're okay.
Right. Okay.
And that's a super reasonable thing to do. All right, so now we have the height, sort of. So we can find the area. So the area, or we know the area. The area is 245, and it's equal to base 1 plus base 2 divided by 2 times the height. So 2x plus 8x is 10x divided by 2 is 5x times 4x is 20x squared. So we know that 245 equals 20x squared. We can solve that for the height, or for the value of x, excuse me. So this one, I'm actually surprised they didn't give you different numbers because it doesn't really work out. I mean, it does, but it's just, they could have used nicer numbers.
Yeah.
But it does actually come out nice, believe it or not. Just isn't as round as we would like normally.
Um, 3.5.
Yes. Okay, now that's enough to be able to find height, which is 4x, and then the perimeter, which is adding up all the x's all the way around. Okay. So first find the height, and then you can either find each of the lengths, the 2x times 5x, or 2x plus 5x plus 8x plus 5x, or you can just add them all together and multiply by 3.5. Totally up to you. But have you work that out here for the height and then the perimeter, please.
Okay. Okay, for height, 14. And then,
I'm sorry, wait, say that again. You said 14?
yes.
Okay, perfect. Keep going.
And perimeter 60,025.
You're adding up 2x plus 5x plus 8x plus 5x. It ends up being 20x. The x's
Oh,
just add together.
I did area, I did multiplication.
Okay. Yeah, we want to be reasonableness of our answer. Perimeter and area are not that much related, but they should be within the same order of magnitude, roughly.
Right, okay.
So go ahead and recalculate that for us, please.
Perimeter is 70.
Yes, you got it. All right. Any thoughts on that before we move on to 17 A and B? I'm sorry, yeah, 17.
Nope, that was good.
Okay. All right. So we unfortunately slow down the speed at which we can do these problems because they just get really, really complicated. Find the area of each trapezoid. So what we really want is we really want this base down here, and we really need this height right here. And the height is actually easier to find in this problem because it's another special triangle, right? It's got a 30, a 60, and a 90 in it. The 30 is always across from the short leg. So the short leg is actually this one right here. Even if it doesn't look like the way it's drawn, you go by the angles, not, your opinion, because your opinion might be biased. Can you tell me the value of that short leg there on the right, or the value of H?
Um, is that one 12 root 3?
Got to go back to where we use these reference triangles, right? And you can draw it. It's not that it's a different reference triangle each time. It's that you got to identify whether you're given the 2x, the x, or the x root 3. Are you given the hypotenuse, the short leg, or the long leg? So in your problem, are you given the hypotenuse, short leg, or long leg?
Hypotenuse.
Hypotenuse. So that's the 2x side. Right, so x is 6. Which is the short leg? Is it A or B?
A.
It's A. And A is just x, which is 6. And what would the other one be? We do actually need it.
That one is that one 6 root 3?
Yes. Very good. So we have the height. Check. We got that. We're feeling real good. We know that this is 6 root 3. Okay. But now we got to focus on this other part on the left here. We unfortunately have to draw yet another one of these things right here. So I'm going to draw this triangle. This angle is now 30 down here. Now where this is. The reason is the whole thing is 120, but if you draw this up and that's a 90 degrees, 120 minus 90 is 30. Okay. And you do know the height. You do know the height is 6. Okay. And you might be wondering, well, why are we doing that? Because we really want this length down here. We're going to get it by figuring out this length at the top and subtracting it from 5 root 3. So if we could figure out the length in red here, that leads us to the length at the bottom. So is the 6 in this triangle on the bottom, is it the long leg, the short leg, or the hypotenuse?
The short leg.
Short leg is always across from the 30. Is the 6 across from the 30?
Oh no, long leg. Sorry, I thought you were asking for the red one.
Yeah, the red one's the short leg. So this is the x root 3 side. Okay, so could you solve that for x for us, please, and rationalize as needed?
Yes. Is it 2√3?
So when you, yes, so it does become 2√3. That's the value of X. And so the reason we needed that is because the length down here that I'm drawing is 5√3 minus 2√3, which is 3√3. Is that okay?
Yes.
So I have the advantage here of being able to grab the figure one more time and kind of redraw it. The total length down here at the bottom is the length you just found, 3√3, plus the 6√3, 9√3. And the height is 6. So you now have enough to calculate the area of the trapezoid. Will you do that for us, please?
Yes.
All right, fantastic.
Wait, when I do 5√3 times 9√3, does it become 45√3?
Well, unfortunately, to answer your question, you have to write the formula and you're adding them. You're not multiplying them.
Oh. Okay.
I think what happens is for example, we do so many problems one way and then we forget, oh, I'm just adding. I don't have to, even though you're used to always doing multiplication with these types of problems. So keep going there.
So then it's 14√3/2?
Yes. And then you multiply by, well, yes, and then divide by 2. So that's 7√3 times the 6.
Right. 42√3.
42√3. Yeah. Tough problem, really tough problem. These C's are just, they're kind of on their own for, we could work them in groups and maybe never figure, fortunately. Okay. So new problem here for us to look at. The make this a little bigger. We're not gonna be able to get through this, I don't think. This angle right here is 30, and we know that because it's an isosceles trapezoid. So like sides, like angles, that means this is 120. Okay, this is also 120 because 30 plus 90 make 120. And we can take advantage of some symmetries here. We know that the whole thing has to be 360, meaning all the angles. And we've already accounted for 120 and 120. So that leaves you with 120 left over to go between the bottom two, or top two, I guess. So this is 60, and this is 60 here. That's not right. That is not right. I apologize. I'm trying to rush through this here. So 120 is divided among, yeah, thank you. There it is. So that's 30. It's 120 divided by 2, which is 60 in each of those. So now you can find the missing sides here. This is, well, you don't need that one. That's 6. Well, you do actually, you need 6. That's 6√3. And then you have enough actually to find this other one. You can drop an altitude down to find it, but you basically have to find the area of the one triangle, which is 1/2 6 times 6√3. plus the area of the second triangle, which is you end up finding 3 root 3 ends up being 3 times 6 root 3, but 1/2 of that. So I know that was really quick, and maybe didn't make any sense, but if you need to get something down, you know how to do it. So we do unfortunately have to stop there. I actually thought we were gonna get done early, but boy, these are long assignments. So
Yeah.